Earth. A place we all know. But this is an Earth where dinosaurs terrorize mankind. Or it could be another Earth, where Russia won the moon race. Or another Earth that could annihilate our own in the blink of an eye. Beyond the faintest star, at the bottom of a black hole, or hidden in higher dimensions, groundbreaking science now suggests there might be more than one version of reality. Are there parallel universes? Space, time, life itself. The secrets of the cosmos lie through the wormhole. Is there more than one of you? More than one of me? Another version of me may look identical, but we're not. Our fates could be completely different. One of us could be a descendant of the other. Our meeting could cause both of us to evaporate into pure energy. We could all be living multiple parallel lives, because as scientists explore the outer reaches of physics and the cosmos, they are beginning to believe that parallel universes do exist, and that they might determine the fate of humanity. When I was in grade school, I was smitten with this girl. I couldn't get her out of my mind. Trouble was, I had a funny way of showing it.
Morgan!
I often wished I could be someone else. Somebody with confidence and charm. I wished I could swap myself out for that Morgan, wherever he was. Cosmologist Max Tegmark of MIT believes that this other version of me, and of all of us, really exists. And he believes our cosmic doppelgangers live beyond the edge of the known universe.
The best theory we have for what made our universe predicts that it isn't just really, really big, but actually infinite, going on literally forever in all directions.
For Max, it's all a matter of statistics. And in an infinite universe, even extremely unlikely occurrences are possible.
If I take 3 rocks here, here's a pattern, orange, white, and black. I'll look around. Oh, here's another one, orange, white, and black. If I take a larger pattern with, say, 10 rocks here, then I have to look a lot harder to find a copy of it. And here it repeats.
Earth is an enormous pile of stones, just as our bodies are enormous piles of atoms. How those atoms are arranged in space determines who and what we are. The bigger the pattern, the further you have to travel before finding a repeat.
When I say all patterns of atoms repeat, I really mean all patterns, even the pattern of atoms that makes up me, Max Tegmark. If I go far enough away, there's going to be another exact copy of me who will not just look like me, but feel like he is me.
Max has calculated the number of light years he must travel to find the same arrangement of atoms he is made of. It's a staggering number of light years.
I came up with 1 with 1,000,000 trillion zeros after it. And that's a huge number, but compared to infinity, which is the truth size of space, I think, it's just in our backyard.
But there's a catch for any explorer daring enough to brave the long trek to meet his cosmic clone. In the 1920s, astronomer Edwin Hubble observed that our universe was not sitting still. In every direction he looked, galaxies were flying away from us. The further he looked, the faster these galaxies appeared to move. Hubble concluded this was only possible if the entire universe was expanding.
If this slab of concrete here were a distant galaxy just sitting still, then I could send messages to it. I could send intergalactic emails at the speed of light. If I'm willing to wait long enough, they'll get there. Since space is expanding, we need to turn on the conveyor belt to make this more realistic. This distant galaxy is actually moving away from me.
The further away from us we try to reach, the faster the space between here and there expands. At a certain point, the expansion is faster than the speed of light. And that means we will never reach or even be able to see anything that lies beyond this horizon.
To me, the bad news with this cosmic horizon is it prevents me from visiting copies of myself and of my friends, which would be kind of fun.
But there is another place to look for parallel worlds. Not in the depths of outer space, but in the microcosmos right under our noses, where nothing, it seems, is solid. Frank Tipler studies the strange laws of quantum mechanics. These laws govern the tiny subatomic particles we are all made of.
Thank you, Adam.
He fuels his prodigious brainpower with the finest cuisine the city of New Orleans has to offer.
I think what I would be in the mood for today is the Schrodinger's Special. All of reality is described by quantum mechanics, and the central equation of quantum mechanics is Schrodinger's equation.
Erwin Schrödinger unplugged reality as we knew it when he wrote down his namesake equation. He proved that subatomic particles could exist in multiple places at the same time, and that more than one particle could occupy the same point in space at the same time. This subatomic world remains a blur of probabilities until the moment someone looks at it, when those probabilities gel into one definite reality. Frank believes this quantum fuzziness doesn't just happen in the microscopic domain. It's the way everything works.
People try to think, it can't be quantum mechanics applies to the universe. Nonsense. Anyone who looks at this Schrödinger equation is forced to conclude that it applies to all of reality, not just to atoms, but to buildings, to glass, to the whole universe.
If Frank is correct, everyday objects are schizophrenic when nobody looks at them. They constantly shift between one of many existences. Underneath this metal hood is every dish that Frank could order, existing simultaneously. And only when the hood is removed and Frank looks at it does one reality take hold.
Veal. Oysters.
But why this dish and not the other? Most scientists believe Frank's observation forced nature to make a decision at random. In the blink of an eye, all other possible realities collapse. But Frank is not convinced the mainstream has it right.
They concluded that when you carry out a measurement, there are possible universes out there which collapse into one real universe. Actually, that is inconsistent with the mathematics of quantum mechanics.
Frank believes that every possible outcome does in fact become reality, each in its own parallel universe. In this universe, Frank eats veal, but in another universe, he ends up with steak. In another, shrimp jambalaya.
In effect, we have always known that reality was more than one universe, but physicists would not believe their own equations.
If Frank is right, the space that you occupy is filled with a near infinite sea of identical copies of yourself. If something happens to you, the exact opposite could happen to one of your hidden twins. But they may not stay hidden for long. On this silicon chip lies a tiny object that can exist in two realities at once. For the first time, this scientist may have caught sight of a parallel universe. Alternate realities don't have to be light years away, far across the universe. They could all be right here. If the strange rules of quantum mechanics are correct, I am really a collection of countless alter egos, all locked in a relentless struggle. This internal war is supposed to be undetectable. At any moment, only one ego can become real. The others are completely invisible. Or are they? Physicist Frank Tipler believes quantum mechanics predicts there are countless versions of ourselves living in parallel universes. And like many of us, he sometimes daydreams of an alter ego.
It's time for another trip around the cosmos with Fearless Frank, astrophysicist and cosmic adventurenaut. This week, Frank discovers a portal to a quantum parallel universe.
This Frank Tipler believes our universe, like a cartoon, tricks us into thinking it's the only reality. From the top down, a cartoon appears to be a single object. But a cartoon is made up of cells.
We can use one transparency to represent one universe, but in reality, there are far more universes out there superimposed on each other.
an unobserved object will be in many places at once. According to Frank, each one is destined to become reality in its own separate parallel universe.
When we make a measurement, each one of the Frank Tipplers would be united with a particular result.
In one universe, the object can only be seen in one place. From our perspective, it appears the act of observation destroys all other possibilities. But appearances can be deceptive.
We shouldn't think of the possibilities just as possibilities. The other realities do not cease to exist just because I have picked one in my own hand. They still remain, they still exist.
If we could see every universe at once, a countless number of Frank Tipplers will make the same measurement at the same time, and each Frank will see the object in a slightly different place. These tiny nuances can, over time, amplify, resulting in parallel worlds with diverging fates. In one universe, a giant asteroid misses Earth, and dinosaurs live on. In another, rocket failure dooms America to lose the moon race. But how can we ever know if these alternate realities exist if they evaporate from view as soon as we look at them?
We never see these quantum mechanical effects like being in two places at the same time because we're always unavoidably measuring things. Air molecules are hitting them, that's a kind of measurement. We shine a light on something, that's a kind of measurement. Perhaps you have an object sitting on a table. The table, because it's pushing back on the object, is also measuring it.
Experimental physicist Andrew Cleland may have become the first man to catch a glimpse of a parallel universe. Inside this small square of silicon, Andrew has etched a barely visible metal paddle. It's made up of over 1 trillion atoms. In the quantum world, it's Godzilla. And he's trying to show that something this large still obeys the rules of quantum mechanics.
We're very familiar with the fact that quantum mechanics applies to small things like electrons or atoms, but the idea that it should also apply to large things, things that we deal with in our everyday life, is much harder to accept.
But proving that his paddle can behave quantum mechanically means making sure nothing measures it. It needs to be in complete isolation and very cold.
So this instrument is a dilution refrigerator. If you have $500,000 lying around, you too could own one in your own home. The instrument has a series of temperature stages that go from 1 Kelvin to 0.6 Kelvin to 0.1 Kelvin, all the way to 20 millikelvin, or in other words, about minus 459 degrees Fahrenheit. This is where we operate these quantum experiments.
Inside the dilution refrigerator, Andrew directs a single quantum of energy at the paddle. It should have a 50-50 chance of either receiving the energy or missing it. Instead, to his amazement, the paddle both receives the energy and misses it at the same time, and begins to oscillate between these two realities.
The paddle can be both in a state where it has no energy and where it has one of these units of energy in it. And in that state, actually, when it's in both at the same time, you actually do get a vibration at 6 billion times a second.
Andrew's groundbreaking experiment proves that the strange laws of quantum mechanics govern everything in our universe, from tiny particles to gargantuan galaxies. No matter the size, any object can be in many places at once.
I thought people within the physics community would notice it and would give it some applause, as it were, but I really didn't expect that it would break outside of the small community that I'm used to dealing with. So that was quite a surprise. There's a number of different interpretations that have been generated to try to explain this. One of them is the many worlds interpretation, or parallel universes. But in the end, those are not predictive. And because it's not predictive, it's not something we can test. So that leaves it open for people to choose whichever interpretation they prefer.
If there are quantum parallel universes, Andrew's experiment could be the first step toward unlocking their secrets. But there's another type of parallel world that nearly all scientists are convinced should exist. It's made of antimatter, and if we ever meet it, the results would be complete and utter destruction. There is something evil lurking out in the cosmos. It's called antimatter. If one tiny drop of it met a drop of normal matter, it would explode with more force than the bomb at Hiroshima. The frightening reality is that the Big Bang should have created antimatter and matter in equal amounts. In other words, out there should be an antimatter twin to our universe with the power to annihilate all creation. There's just one problem. This deadly antimatter universe has gone missing. Joanne Hewitt is a theoretical physicist at the Stanford Linear Accelerator in California. She's a detective on the trail of this missing parallel universe.
Where did it go? That's one of the big mysteries of science today, is where did the antimatter go? Every particle has its own antiparticle associated with it. It has the same mass as its parent particle, but it has all the opposite properties. Like an electron has an electric charge associated with it, so an anti-electron, which is called a positron, has the opposite electric charge associated with it. When antimatter and matter collide, basically you get a big burst of energy, just like boom.
If the Big Bang created as much antimatter as matter, then one of two things should have happened to it. Any particles of antimatter and matter that bumped into one another should have been completely annihilated. But some antimatter and matter may not yet have met, and an explosive reunion could be coming our way. Joanne has made it her business to find out. She harnessed the power of Stanford's 2-mile-long particle accelerator to recreate miniature versions of the Big Bang.
We created two beams of particles, and we collided them with just enough energy to create a pair of particles called B mesons.
Inside their experiment, called the B Factory, Joanne and a team of scientists tracked a swarm of B mesons and their antimatter twins known as anti-Bs. They looked for any subtle differences between these supposedly equal and opposite particles.
If you want to study the B meson versus the anti-B meson, you have to be able to see the difference in the time between which the two of them decay. But they live for a trillionth of a second. It makes them very difficult to study.
With the help of sophisticated instruments, Joanne and her team discovered a tiny difference between the B and the anti-B.
One will decay just a little bit faster or a little bit differently than the other one. And it's the anti-B meson that decays just a little bit faster.
This tiny imbalance between matter and antimatter could make a big difference to what happened after the Big Bang. In fact, it could make a whole universe of difference. Think of matter and antimatter locked in a game of checkers to the death. Both sides start with equal numbers. As time goes on, most of the checkers and anti-checkers annihilate one another. But in the end, one side has a slight edge and claims victory.
This one single checker out of an entire group that was created from the Big Bang is all that exists today, and it is the entire matter content of the universe.
The matter we see in the universe today is just a tiny fraction of two vast seas of matter and antimatter. They would have completely destroyed one another were it not for the tiny imbalance Joanne and her colleagues found between the B and anti-B mesons.
Because of the slight difference in the decay properties of the antimatter, we're left with matter today, just a sliver of matter compared to the original amount at the Big Bang.
So Joanne's detective work is done, and everyone can stop worrying about our impending annihilation with an evil antimatter universe prowling in the dark recesses of space. Actually, this story may not wrap up so neatly, because even though the B Factory results explain where most of the antimatter went,
unfortunately, that doesn't account for all of the missing antimatter in the universe. So there must be some new piece of physics that is still there for us to discover.
3, 2, 0, and liftoff for the final launch of Endeavour.
that discovery could be close at hand. In May 2011, the Space Shuttle Endeavour delivered a giant particle detector called the AMS to the International Space Station. The AMS will look for the cosmic rays created billions of years ago from matter and antimatter annihilating in the wake of the Big Bang. Perhaps they will lead us to the remnants of that primordial sea of antimatter, if it's out there. The antimatter universe is not the only strange domain that may be lurking on the fringes of our cosmos. We could be surrounded by all manner of parallel universes. Learning where and what they are is not just a theoretical game. The fate of our entire universe depends on it. Why do we care if another version of you and me exists? We're never going to meet them face to face. But these alter egos are important because they are the key to answering the biggest questions of existence. How was the universe born? And how will it end? Cosmologist Andrei Linde believes he's made a shocking discovery. The force that created the cosmos should have created countless other parallel universes. And that same force would also cause the demise of everything we know. This discovery began with a simple, seemingly innocuous question.
Why does the universe look the same in every direction that we look? This is the problem which bothered physicists for, hundreds of years.
Andrei was convinced that a massive chaotic explosion alone could never create the smooth and uniform universe that we see today. Because the way physics understands the Big Bang, everything we see today exploded from something the size of a sugar cube.
It appears that in order to create all of these galaxies surrounding us, in the standard Big Bang theory, we would need approximately 10 to the degree 85 tons of high-energy explosive. It's like a billion of 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 a billion tons of matter. And this just sounds totally unbelievable. And that's why it was necessary to come with a different kind of story. And that was the inflationary theory.
Inflation is a process Andrei knows very well, and not just as a force that blows up the universe. When he's not decoding the mysteries of the Big Bang, he inflates tiny portions of our world with his favorite hobby, photography.
This is actually a pretty nice camera. My family gave it to me as a birthday present when I got 60. And since that time, I've got kind of hooked.
According to Andrei's theory, when the universe was the size of this sugar cube, it must have been a chaotic lump of energy, each microscopic part a fundamentally different place from another, like the Technicolor patchwork.
This cube may have different colors of a different size, but what inflation does, if you start with any tiny corner of the sugar cube, then this part of the universe expands. And we look around, we're living inside this sugar cube, everything is white around us, or everything is pink around us. And we say, oh, so beautiful, our universe is uniform. We solved all our problems.
But inflation may not solve all of our problems, because once it gets going, inflation, like Andrei's addiction to blow-up photography, never stops. The universe, it seems, is constantly growing larger and larger forever. But according to Andrei, inflation must also come back to visit our already expanded universe. It zeroes in on a tiny fraction of it and blows it up into a new universe.
So what will happen, there will be a bubble formed of a new phase, if you wish, and the bubble wall will grab you and kill you, and, well, that will be the end.
If Andrei is correct, our universe is inherently unstable. At any moment, one tiny part of it might expand to cosmic size and destroy everything we know. But across the continent, a former colleague thinks Andrei has got it wrong. Paul Steinhardt is the Albert Einstein Professor in Science at Princeton University, a title that only 2 scientists have ever earned.
What does inflation actually predict? Well, if any possibility can occur an infinite number of times, there is no prediction that such a theory can make. Anything that can happen is consistent with such a theory.
Paul is scrapping decades of work on inflation for a new theory, one that claims there is a hidden 4th dimension of space, and across that dimension lies a parallel universe.
Our 3-dimensional world can be viewed as a membrane-like surface embedded in a space with an extra 4th spatial dimension. So think about these 2 newspapers here and how close they are together. The 2 brain worlds, ours and the one opposite, are separated by a much tinier distance, about a trillionth of an inch.
In Paul's model, everything in our universe lives on a flexible 3-dimensional membrane, or brain world. The other brain world even though it's incredibly close to us, is a separate universe that does not interact with us. But then Paul began to wonder what would happen if it did.
What my colleagues and I began to think about was the idea that these brain worlds might not just sit there for all time, that they might begin to move towards one another and actually collide. In that collision, energy would be converted from the energy of motion of the brains into matter and radiation, so that when they came apart again, they would be filled with hot matter and radiation, just like one would get after a Big Bang. In fact, we realized this could be the Big Bang. The Big Bang, instead of being the beginning of space and time, could actually be a collision.
Paul believes that this alien universe is still less than an atom's length away. It's a strange domain where the laws of physics are completely different. And Paul thinks we're already picking up evidence of it.
Although we can't touch, feel, or see any matter on the other brain, we can nevertheless sense its existence, because we can feel its gravity.
In the past decade, astronomers discovered that every galaxy is surrounded by invisible, supermassive sources of gravity. No one is sure what these hidden behemoths are made of. They call it dark matter.
The matter that's on the other brain world, which from our vantage point appears to be a kind of dark matter, doesn't interact with the light on our side.
Could dark matter actually be matter in a parallel world? Paul thinks we may find the truth at the bottom of a black hole, a vast sinkhole in space where gravity is so intense nothing can escape it.
If a lot of matter clusters together on one brain or the other brain, its gravitational field becomes so strong that it draws the other brain towards it near that point. And what happens is as if you've pinned the two together at that point where the black hole formed. So elsewhere, the two brains may be separate, but at the point where they're pinned, they're joined together at the position of the black hole.
Decoding the riddle of dark matter is one of the biggest challenges in physics today. Thousands of brilliant minds and hundreds of telescopes are trained on it. Paul believes that when they finally learn what dark matter is, they will actually discover that it exists in another universe. Do black holes connect us to a parallel world? This scientist may already have the answer, and if his new theory is correct, we could be on the verge of making contact with a parallel universe. 400 years ago, it was believed Earth was the center of the universe. Then a man from the village Torun in Poland swept the Earth aside. But in discovering our true place in the cosmos, the great astronomer Nicholas Copernicus left one crucial question unanswered. Where is the center of the universe? Now another son of that same village thinks he has the answer. If he's right, it could lead us to a parallel universe, one that gave birth to ours. Nikodem Poplawski has the same revolutionary spirit as his Polish predecessor. He believes the key to making a scientific breakthrough is rigorous training and a clear head.
When I work out, I have some freshness in my mind, and then I want to think about some problems about the universe. I become more creative.
Nikodem's intense focus brought him face to face with a cosmic monster, the black hole. Inside its outer edge, known as the event horizon, not even light can escape its voracious appetite. No one is sure what happens past this cosmic point of no return. At the heart of a black hole, the force of gravity is so powerful that it will compress the entire mass of a star into a single point. Physicists call this point of infinite density a singularity.
And of course, singularity means that we do not understand completely the physics. I don't like singularities, and I wanted to see if there is a mechanism which would be the simplest and the most natural.
Like most scientists who study gravity, Nikodem is a disciple of Albert Einstein. Einstein professed that space and time are woven together into a flexible fabric he called space-time.
Katie and Megan are holding here a towel which represents space-time. Space-time can be curved under the influence of massive objects. So here I have the ball which represents the sun. Sun has some significant effect on the space-time. You can see how space-time is curved, and here is Earth. And Earth feels curvature of space-time, and that's why it moves around the sun.
But this curving was not the only way Einstein believed matter could distort the fabric of space-time.
In addition to curvature, Space-time is also equipped with another geometrical property called torsion.
Albert Einstein and mathematician Élie Cartan believed matter could also twist individual fibers in the fabric of space-time. However, the effects of torsion are so tiny, they are impossible to measure. Without any means to test it, Einstein and Cartan abandoned the theory. But Nikodym picked up where they left off. He applied their theory to the unforgiving gravity inside a black hole, where matter spins so fast, torsion twists space-time into a coiled spring, waiting to explode.
So here is the collapsing black hole. Tornado in a tube visualizes the very violent dynamics of the motion of the matter through the event horizon. At extremely high densities, torsion starts becoming significant and manifests itself as a force that opposes gravitational attraction.
As matter approaches the heart of a black hole, torsion becomes so extreme that it spins the matter around with intense force. Matter does not fall into a singular point. Instead, the heart of a black hole is a swirling opening.
The matter cannot just disappear, the energy must be conserved. So all the matter goes through the event horizon from a black hole to the growing white hole on the other side and participates in creating new growing universe.
If Nikodym is right, when the mass of a star collapses into a black hole, it spews out on the other side as a white hole, an explosive fountain of mass and energy in a new parallel universe. But this idea does not just apply to black holes in our universe.
If we assume that every black hole produces a new universe inside, then our universe must have been born in a black hole which exists in another universe.
Nikodym believes the Big Bang that created our universe was actually a white hole, created in turn by the death of the star in another cosmos, a cosmos that is our parent. And if this theory is correct, there should be a cosmic umbilical cord between these two worlds, one that has never been severed.
If we are inside a black hole, then there must be a connection from the parent universe to our universe.
Has this scientist stumbled upon a bridge to another universe? And could strange bursts of energy in the night sky actually be something totally unexpected? Messages from the inhabitants of a parallel universe? Black holes are the most terrifying things in the universe. Anything that falls into one is gone forever. But where does it go? The answer could be another universe. If this idea is right, black holes might be a way to send a message to a parallel world. And there's another possibility. Beings from another universe may already have tried to make contact with us. Physicist Nikodym Poplawski is convinced that our universe rests at the bottom of a black hole in a parallel world. And he's trying to discover whether beings in that parallel world might have a way to communicate with us.
And this is a visualization of what happens to the matter and energy when it goes to a black hole.
The gravity inside a black hole is so intense, if you jumped into one, it would rip apart every atom in your body. But that doesn't mean nothing can survive the trip.
Now I'm going to write the word space-time in Polish. Czasoprzestrzeń. Now I'm going to rip it off, and I'm going to put a little piece of paper to the blender. And I'm going to press the button. No matter how long I'm going to press the button, the information is still there. Now it's very distorted. We cannot easily recognize it. However, it is inside a black hole and it will appear on the other side inside a white hole. And we can hope that one day someone will be able to decipher this information.
Could our cosmic parents be sending us messages? Nikodym thinks we may already have detected evidence that they are. For decades, astronomers have picked up powerful bursts of energy coming from the farthest reaches of the cosmos.
Gamma-ray bursts are the most luminous explosions that we observe in our universe, besides the Big Bang. And we still do not understand well the mechanism that causes them. We see them coming from far, far away, they may be indications of matter coming from the parent universe to our universe.
Could these pulses of energy actually be a form of Morse code from inhabitants of another universe? A message of profound cosmic wisdom based on billions of years of experience before our universe was even born? Nikodim's theory is still young, and the math is intimidating. He could be wrong. But in his struggle to wrench parallel universes from the realm of fantasy to one of serious scientific possibility, he is far from alone.
Once you consider the full multiverse point of view, you see a much broader picture of reality.
Whenever two different things happen, you would just be aware of one of them. You would think mistakenly that the other outcome didn't happen, but in fact, the other copy of you would feel just the other way around.
We start discussing things which previously belonged to the realm of science fiction. We are right now thinking about this very, very seriously, and maybe eventually we will find some answers.
The word universe is supposed to mean everything that exists. Today, we're almost certain that our universe is not all there is. There really could be parallel Earths, parallel yous, and parallel me's. It's hard not to wonder what our alter egos might be like, whether they are living out our most cherished dreams. But don't forget this possibility. You could already be living the dream of another you from a parallel universe.